straightforward and simple that it works out to being just something that we can do by counting. We all, if we just look at, if we look at the squares on the floor, the squares on the floor are 16 by 16 inch square tiles. But for us, I don't care about what the dimension is. I'm just going to count them. Okay. So let's say I wanted to start walking from here and I wanted to walk back to the last row. What I would do is just count my squares. So I'd say here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took me 12 squares to get back to the row back here, starting at my blue line. All right. So the distance from there to here, I'm just going to say is 12. Are we okay with that? Okay. Now, if I start over, let's say I only go 4 squares. How many more I have left to go? Hey, what did you do? Math. That's very good. You did some math. Nice job there today. All right, very good. You did some math. In your head, what you saw was going from the beginning, I started here. I had to go to here. I know that the overall distance was 12. I know that I stopped here, and this much was 4, which meant that the leftover has to be 8. Because do you agree that by walking from here to the back, I'm walking in a straight line, but technically it's a 7 at the beginning and an end. That segment was continuous, and along the way, I stopped. Was my stopping, my rest stop, if you will, was it collinear with the other points? I was staying along the same line, but if I went 4, I still had to go another 8 to get to the end. Okay? So what this means is that we can do something called segment addition. Segment addition is nothing more than 2 smaller segments added to a larger segment. Segment plus segment equals bigger segment. Segments must be collinear. Oops. That's really the only thing that has to happen. The points must be collinear. I can add up however many spots I want to go. I know the overall distance. I know so far. I just do a little math, if you will, and I get the right spot. Again, notice it's not difficult. It's the idea that you've done this before. How many of you guys ever use a tape measure or a ruler and you had to go 1 foot and then move the ruler, go another foot, move the ruler, go another foot? And you had to continually do that just to add stuff up. All you were doing was using segment addition without knowing you were using this thing called segment addition. Because you're just going in a line along the same path. It's just counting up the steps, counting up the inches, however you want to do it. Okay? The only thing that'll change now is that we put letters in it. A, B, and C. What are the 2 smaller segments? A, B, and BC. What's the big segment then? AC. So in my head, I can now say that AB plus BC has to equal AC. I am taking a very simple algebraic problem and I'm referring it back to lettering within geometry. Like I said before, most of the math that we're going to do relates back to simple stuff, but you have to visualize it from algebra. Yes, ma'am? When we get into writing stuff out like this, I won't use lines a lot of times because it gets very cluttered. Okay? There's a time and a place for doing that, and even textbooks don't regularly use that either. If you do, it's fine. You're not wrong. But you see how it can get kind of cluttered? So if I say that this is 4 and this whole thing is 17, what's BC? 13. What did you math so fast there? Exactly. You know that the AB is 4, BC is something, and the whole thing is 17, so you subtract 4 and you got 13. Again, you're going to set yourself up very fast, one step, maybe a two-step equation, depending upon the type of problem. You're taking algebra that all of you guys can do all day long and looking at it in terms of a geometry problem. All right? Let me show you another one. Let me write this a little bit larger. You have segments EF and FG, and it tells you that the entire segment EG equals 59. Sometimes you will see in directions, it'll say points E, F, and G are collinear, and then therefore you know that the rest of this stuff has to happen. Because sometimes they won't give you a diagram, you have to make one. But tonight we'll have diagrams. So when you look at that, what are the two smaller segments? EF and FG. What's the whole segment? EG. So that means that I can take the two smaller segments, add them together, and it has to equal the whole thing. I know that I can write out in terms of letters, EF plus FG has to equal the whole thing, EG. Well, according to my diagram, yes, sir. I do not. Yes, sir. In this case here, what's EF equal to according to the diagram? Ma'am. Oh, the 59, it was in the problem over here, but I ran out of space. I wanted to blow this picture up a little bit to show you. It'll be given to you. All these parts that you need to solve the problem will be given to you. I just blew the picture up so you can see it better. Okay? Same person. People ask that second hour too. Where did that come from? Just made it up. Okay? So you start filling in the blanks. EF is 8x minus 14. FG, 4x plus 1. Whole thing is 59. Now you're at a two-step algebra problem, but you have to do one thing first. What's that? Excellent. You gotta combine like terms. Again, it's nothing that you haven't done before. What's 8x plus 4x? 12x, good. What's negative 14 plus 1? Good. Now you're back to a very straightforward two-step algebra problem. Working backwards from order of operations, what do you have to do? Add 13 to both sides. Excellent, excellent, excellent. So 59 and 13 is how much? It's okay. And then what do I drop down on the other side? 12x. And I heard someone already say it too. Good. That gives you how much for your value of x? 6. Now, here's where geometry gets to be a little bit different. In algebra, 8 times out of 10, you were just solving for x and didn't have to do anything else with it. Every once in a while, you might have to do something with it. In geometry, it's more often than not, you're going to have to do the next step. In this problem, I shrunk it so you can see it better, but the original problem stated, what are segments EF and FG? That would be the type of thing that would be written out in a textbook, type of thing written on a worksheet, anything along those lines, where you're not only solving for x, you have to go back and substitute in to find the segments. So here we know that the value of x is equal to 6. Exactly. So then you would take that value of 6 and say, all right, well, what's 8 times 6, subtract 14? What's 4 times 6 plus 1? I would figure out those two numbers, add them together, make sure you still equal 59, you're good to go. All right? It's not that the algebra shouldn't be the deterrent on any of this stuff at all. Because the algebra is going to be easy. It's just the remembering that you have to go back and do something with it. So I know the FG is pretty simple. That's 24 plus 1 is 25. Is the other one 34, I hope? True, but you want to make sure you didn't screw that up. So just to be on the safe side, 48 subtract 14 is still 34. Add them together, you get 15. Now, this is our kind of first step beyond just labeling and looking at pictures and stuff like that. This is kind of our first step of how geometry is going to look kind of almost on a daily basis. You've got definitions and stuff that are geometric in nature, but what you use at the end of it is still algebra. Okay? So don't freak out when you see words and letterings and stuff like that. Remember what it stands for. Segment addition, when you have things that are on that same line, you just add them together. From here to you guys for 12 steps, if I go 2 steps, how many more I gotta go? It all boils back down to just being able to count. And that's the idea. Can you count how far things are? Decent? I believe I already posted the problems for tonight. I want to say it was, let me write it down here for you guys as well. Yeah, it was on page 24. Oh yeah, if you forgot, make sure at some point in the day, if you don't think you have reliable internet sources or whatnot, make sure you screenshot the page. Make sure you, if you have to, I usually have a textbook lying around. It's usually on one of the front desks up front because I usually forget to put it away. But if you need to take a quick picture of the textbook before you leave to get the problems, by all means, do it. That's what it's there for. All right? We'll get further involved with this tomorrow. We'll talk about what's called midpoint. We'll talk about how we set, whether or not we set things equal to each other. We set them equal to the whole. We do a little bit more algebra between tomorrow and Friday as well.